Projectile motion. A gun fires a shell at an angle of elevation of 30 degrees with a velocity of 2 times 10 raised to the power 3 meters per second. What are the horizontal and vertical components of the velocity? What is the range of the shell? How high would the hull rise? A situation to this question looks like this. You have, if this is a level ground, then there is an angle of elevation where the gun is being fired. The initial velocity u is the angle. It will move and drop to the ground. The question asks here, we need this angle, which is unknown. This angle is 30 degrees, that's given to us. The initial velocity is given. The arcs of the vertical and the horizontal component. So this down to the ground, create a right angle triangle. These will be the vertical component of the velocity, and this will be the horizontal component of the velocity. Question need a range. The range will be the distance from where it was fired, this point, and then the maximum height, the highest distance, vertical distance, that's h, this point here. The situation of the question. So let's list the information. Angle is given 30 degrees. Initial velocity 2 times 10 raised to the power 3 meters per second. Horizontal component of the velocity is needed. Vertical component of the velocity is needed. The range, and then the maximum height. Let's start with the horizontal component. The expression that's linked is u cos theta. Putting in the value, u is 2 times 10 raised to the power 3 cos theta. Theta is 30 degrees. That will give us 2 times 10 raised to the power 3 cos 30, 0.8660. That will give us the horizontal component to be 1732 meters per second. The vertical component is expressed as u sin theta. Putting the value also 2 times 10 raised to the power 3 sin 30. 2 times 10 raised to the power 3 sin 30 is 0.5. The vertical component will give us 1000 meters per second. The next is the range. The expression for the range is given as u square sin 2 theta all over g. We substitute the value. The initial velocity is 2 times 10 raised to the power 3. You square that. Sin 2 theta is 30 degrees. Acceleration due to gravity is 10. I have there 4 times 10 raised to the power 6. If you open that, that's sin 60 all over 10. 4 times 10 raised to the power 6 sin 60 all over 10. The entire expression using a calculator will give us 346,410 meters. We're putting that in standard form. The range is equal to 3.5 times 10 raised to the power 5 meters. Then we solve for the maximum height, h. The expression for that is given as u square sine square theta all over 2g. Substitute the value. The value for the initial velocity is 2 times 10 raised to the power 3 square sine 30 square that 2 times 10. Simplifying further, that's 4 times 10 raised to the power 6, 0.5 square all over 20. The whole expression for the maximum height will be 50,000 meters.